was surprised that the skull wasn't more complete. I thought you had this full, because I've always seen the models in the museums of the full skull. How did you figure out what the shape of the skull? Was it based on these bones, or did you have other fossils to go from?
So the shape of the skull is based on the fossils that we have, and so we have the parts that have the eye and the brain case and the back of the snout. We don't have the tip of the snout, which is unfortunate because we don't know where the nasal opening was, therefore. However, we did find the whole lower jaw, so we do know how long that snout was. We don't have a sense for its exact shape. So that's based on related animals. Those related animals all have the nasal opening way in the front. So those related animals would be Cuchicitus and Pachycetus. Those have their nasal opening way in the front, so it's likely that Amniocetus had that too, but we don't know that.
When this video series was being filmed on location at the University of Michigan in Ann Arbor, the executive producer noticed a discrepancy between museum drawings of Rhodocetus and the fossils. The reconstruction of Rhodocetus had a whale fluke, but there were no fossils of the tail to confirm this. Dr. Phil Gingrich, the scientist responsible for the discovery and reconstruction of Rhodocetus, was questioned how he knew there was a whale fluke on Rhodocetus, since that part of the fossil was missing.
What was the reasoning that the scientists think there was a fluke on Rhodocetus based on the other pieces of anatomy?
Well, I told you we don't have the tail in Rhodocetus, so we don't know for sure whether it had a ball vertebra indicating a fluke or not. So I speculated it might have had a fluke.
Scientist Gingrich also acknowledged that the flippers were drawn on the diagram without these fossils. Now, he does not believe this animal had flippers. Again, his answer was surprising, since the museum diagrams had flippers on Rhodocetus.
Now, since then, we've found the forelimbs, the hands, and the front arm, the arms, in other words, of Rhodocetus. And we understand that it doesn't have the kind of arms that can be spread out like flippers are on a whale. And if you don't have flippers, I don't think you can have a fluke tail in really powered swimming. And so I now doubt that Rhodocetus would have had a fluke tail.
Many experts consider whales to be the best fossil evidence for evolution, but are unaware of these discrepancies.
What is unique about this skeleton that tells you that it's a whale as opposed to just a big land animal?
This is the tympanic of a bowhead whale. It's also called the bulla. Basically a bowl-shaped bone with a cavity in the middle. On one side of the bowl, the bone is very thick. That's called the involucrum. On the other side of the bone is very thin, and it's got this crest called the sigmoid process. That shape you find in all modern and fossil whales, including much smaller ones such as this modern dolphin, where you also see a very thick part to the tympanic. on one side, that's the involucrum, and on the thin side you see this crest, this wavy crest called the sigmoid process. So this is the tympanic of Ambulocetus. That's the whole bone. This one is somewhat crushed. Usually there's a cavity in the middle, and then the part on the inside is called the involucrum. On the outside, this ridge is the sigmoid process.
Now, is that sigmoid process unquestionable? Because I know that on Pachycetus there were some questions about that one. It was more like a plate or something. Is this one?
No, this one is as questionable.